Hello, in this video I will show you how to use this runtime caching group of properties, and it works only if you demolish your object at runtime, and it works only for mesh object type. So in this example, the first column I will demolish without using runtime caching. It's disabled here, just to show you the problem. So here you can see my column object, and its mesh has uh, 3,413 vertices, which is uh, not small amount of vertices, and almost 2,000 trees. So this is not a low poly object, and I want to demolish it to 50 pieces, so that will take some time. So let's see how much time it will take. So I will initialize this rock, and now you can see here. So it frame per second dropped almost to 15 frames. And you also can see that there was a significant slowdown here. Again, I will turn on it. So obviously you will not you will not demolish your column with such amount of triangles to 50 fragments in runtime, because it's not appropriate to drop frame per second to 15 frame per second. So this is when runtime caching may help you. In this case, I will turn on runtime caching, and I will set it to by fragments per frame. There's also by frames option, but basically they work in the same way. If you will set by frames, then you can define here amount of frames it should take to fragment this amount of fragments, or you can set by fragments per frame, and then using this value you can define how many fragments it should create every frame um, to cache all the meshes, and only then object will be demolished. So now I will show you how this works. So the same column, the same amount of fragments, and now I will initialize this rock. Now you can see it hit the column, but it not demolished, and only after a few frames it was demolished and crumbled down. And again, you can see, let me repeat this. Take a look at Profiler now. So now you can see that there was no huge frame per second drop, but as you can see, it calculated by one fragment every frame. So amount of frame per second was higher than 30. So in this way, you can kind of spread fragmentation of one object to several frames. So it won't be demolished instantly, but over some time. And when all the meshes will be cached, only then object will start crumbling down, and it will create all the fragments. So this is how works runtime caching for this column. But there is also another way to use this feature. So in this case, I will turn on the skip first demolition checkbox, and when this checkbox is on, it allows you to use first demolition kind of initiation for runtime caching, but when all the meshes will be cached, object will not be demolished, and it will wait for next demolition to happen, and only then it will create the fragments using already cached meshes. So here I have two rocks. So again, I will start play mode and initialize first rock. And now I will select my column. So take a look at Profiler again. So now it's starting caching all the meshes, but now it says here 46 meshes pre-cached, but nothing happens. Object still stays intact. And then I can select my second rock, initialize it, and this time it will demolish all the fragments instantly. So it will create all the fragments at the first contact. And as you can see, basically you fragmented your column to 46 pieces, and without huge frame per second drop. So this is kind of the way to break in runtime your high poly objects. Or maybe you want to create a lot of fragments, and this way you can spread fragments generation over several frames. Again, I can show you one more time. So first rock initiate caching, and second rock finally demolished. And again, just one more, I will say one more time, there was no any assets used for the fragments. The object was fragmented in runtime relative to contact point. So this is a way to use this runtime caching group of properties. So thank you for watching, and see you next time.